free fall problems. So I'm going to go over some problems to be able to use the constant velocity when we're using gravity, which is g, which is a minus 9.8 meters per second squared. So I have a problem here. A ball is dropped from a 70-meter tall building. How far will the ball have fallen at 3.5 seconds? So this is definitely where you want to start drawing your pictures. So I got a building that's 70 meters tall, high, whatever you want to call it. So this is my dy, because now I'm in my vertical position. My distance is in the y. And then it says there's a ball, and it's not going to get pushed, it's not getting thrown down, it's not getting thrown up in the air, it's just dropping. So that means V0 starts at 0. And then it says, where is it? So we're looking for the distance when it's at time of 3.5 seconds. So the t is at 3.5 seconds. So if you look at the equation, equations that I brought, these are velocities, gravity, and time, but I don't know the velocities. This one has distance, gravity, and velocities, but it doesn't have time, so the only equation I can use is this one. So if I'm going to use d, that would be final, is equal to d0 plus v0t, and then I'm going to use the minus 1/2 gt squared. So if we say this building, so it starts at d0 is equal to 0. This is my starting point. Everything is 0. So that means we're looking for a certain d for a specific time. So it's nice when everything starts from rest. So then this goes to 0. The velocity initially starts at 0. So then this goes to 0. So I'm left with d is equal to a minus 1/2 gt squared. And I always know g is 9.8 meters per second squared. Notice I'm leaving g as 9.8. The negative, okay, goes with the equation. Don't worry about putting negatives in your g's. When you do it this way, the negative is already in the equation. And so now I can say when t is 3.5, so that means d is going to be a minus 1/2. It's the 9.8 meters per second squared, and then the t is 3.5 seconds, and we're squaring that. So if you take the calculator, so I always start with the highest order, which is the square. So I do 3.5 squared times 9.8 equals, and divide by 2. I'm getting 60.025. So, and then this is second squared. The second squares cancel out, and we're left with a meter. So the ball is almost to the ground. It's about right here. It's at 66.025 seconds. Very close to the ground. So that is 1. Now let's look at it if we actually used some velocity. So the next problem I have, so now we say the ball basically is dropped from the same building. So that's the 70-meter tall building, but it's thrown with an initial velocity of 3 meters per second downward. A is what would be its position, let's say at 2 seconds, so similar to the problem. And then another one I want to try to find is what would the speed be at 2 seconds. So let's draw our picture. So I got same building, it's 70 meters tall, but now I got a ball and it's being pushed down with an initial velocity of 3 meters per second. I still have my g of 9.8 meters per second squared, and I'm looking for its position, so I'm looking for what d would be when t is 2 seconds. And then I want to know my velocity, which is regular v, at 2 seconds. So we use the same equation, that d is equal to d0 plus v0t, then minus 1/2 gt squared. So d0, it's still starting at 0, so d0 is 0. So this goes to 0, but this is not 0 anymore. So now my equation is d is equal to v0 times t minus the 1/2 gt squared. And I have the t is 2 seconds, I have my initial v0, and I have my g. So the d is going to be the 3 meters per second times the 2 seconds minus 1/2 9.8, sorry I'm squeezing this in, 2 squared. Ooh, there you go. So the d is going to be, what, 6 minus 2 squared times the 9.8 divided by 2 minus 19.6. Oh, and the velocity is also in the negative direction. I'm sorry, I forgot that, because I know we're supposed to be adding these. So this would be a negative and a negative, so you're going to add those. So D is going to be 25.6 meters. Okay, and now my second problem is, what is the speed at 2 seconds? So that's a different equation. So now we have to look, so we're looking for the final V. We have V0 is minus the 3 meters per second, and we have our G of 9.8. And the time is 2 seconds. So we have V's, G, and a T. So if I look at my three equations here I modified, it would definitely be this one, because we have V's, G, and a T. So we're going to use, for the second part of this problem, we're going to have v is equal to v0 minus gt. I'm going to modify that because I have a negative there. So the final velocity is going to be a minus 3 meters per second minus 9.8 times 2. So 2 times 9.8 equals 19.6. So you got 19.6 plus 3. So the final velocity, it's going 22.6 meters per second. And we're going to just call that a negative because that means the direction is down. Oop. So sorry. I have to look up. Hold on. So, I guess you stopped here. So it was minus 3 meters per second minus 9.8 times 2, which was the 19.6. And so it came out to be a total of minus 22.6 meters per second. So it's not increasing or decreasing. This negative is just showing you direction, so it's the downward direction. And that's about all I have time for in this video. I will do a few more problems with ball being thrown up.